This is about the design of piles with pile capes, right? And in this session, we will be again calculating the pile capacity from the graphs or the Excel sheets given by the geotechnical consultant. And then we will move towards the modeling and design of pile and pile capes. The superstructure is the same, and we will take the same 12-story building, which we designed the pile raft system in the previous session. Now, in this case, the substructure, if the designer want to use pile with pile cape system instead of raft pile system, then all of the loads, total load will be registered by the piles, right? So these are the some reactions which I have taken from the model. So let us go to the model. And this is the 12-story building in which I have shown, because I'm skipping some of the detailing because now you are familiar with all of these procedure, and these are the service load combo uh, reactions. And you can see in the interior column, the maximum reaction for the service combo is 1753 kip, right? And you have to select the maximum from it, and it is 1753. It's, you can say 1754. And for the H columns, the reaction is 1148, and it is 1152, and you have to select the maximum from it. And for the corner, you have to select the maximum as well. In this corner, it is 822, and on the other corner, it is again 832. So there may be some difference in between the kips, 2, 3, 5 kips. That is not big deal, but there should be no such significant difference. So I have selected these reactions, which is 1754 kips for the interior columns as a service load. And this is the 1196 kip for the exterior column, which is the H columns. And for the interior, I have selected the value 823 kips, which is the corner columns, right? So the next step is to calculate the number of piles to resist this much service load. So you have to calculate the number of piles, but before going to calculate the number of piles, you have to select the bar dia, bar length, and the capacity, and then you have to divide that capacity of single pile by the total load, right? So again, we are using the same graph, and we have the demand of 1754 kips, and then we have two options. We can use a single pile of 30 inches dia with 80 feet length under one column, right? And with this, there will be no punching issue because the pile and the column will be directly in contact, so there will be no punching issue. And if you calculate the number of piles, so the capacity of one pile having 30-inch dia and 80 feet length, its capacity is 1890, and the demand is this, so you will need only one pile, right? The second option is that you can use two piles. For example, if a designer want to use two pile of 18 inches dia with 80 feet length under the one column, right? So then there will be a pile cape must be designed for punching as well, because there will be no direct contact in between the column and the piles, right? So in this case, the capacity of one pile is 1010 kip, and the demand is 1754. So the number of piles you need to provide is two piles, right? So again, it is up to the designer which option he is opted, but he can use any combination, but we will use option one, in which we will only need one pile under each column, right? So this is for the interior. Similar procedure is for the other columns, that for the exterior, the H columns, the demand is 1196 kip. And again, you have two options, whichever you want to adapt. And you can use the single, only one pile having 30 inches dia with 60 feet length under the column. So there will be no punching issue, and you need only one pile. Again, there is another second option. You can use two piles having 24-inch dia with 40 feet length, right? So again, we will use option one. So I'm using option one because there will be economical, because of the boring cost and the reinforcement and the concrete, and if you can end up with the one pile, so it will be economical. Similar for the corner column, the demand is 823. You can use a single pile 24-inch die with 60 feet length, or you can use two piles 30-inch die with 20 feet. In this case, you can use this will be economical because the total bore length will be 40. In this case, the total length will be 60. But again, you will use option 1 because for the simplicity and to control the punching in the pile cap, right? So again, the demand is 823 and the capacity is 926. I have taken it from the graph, and you will need only one pile under this column, right? So let us go to the model, and you have to unlock the model, and again you have to insert the, you can see these columns. Under these columns, the length of the pile will be 80, and at the edges and the corner, the length of the pile will be 60 feet. So you have to modify the story. The pile tip, this is already 80, so you can write the 80 feet, right? 80 feet pile, right? And you can insert another story, add new story, add with the elevation, and now it will be at -60. So you can write the name of this story as 60 feet pile. Click on OK. So now these stories has been added. Now you can model your piles, right? So let us go to the basement. So now when you draw a pile in here, so if you go down, 60 feet pile will be modeled, right? And then you have to replicate into the 80, so it will become 80 feet. First of all, you have to go to define the pile property, which is already defined in the previous session. And you have to model, define it, pile 30 inches die, right? And the material property is 3000 and it is 30. Click on OK. Take the copy of it and define the pile 24-inch die. now you can draw your piles, right? Click on this quick command and select the property of the pile. Example, select 13th die, and now you have to draw the piles one by one. Right, so when you draw this, select these piles and go to the edit replicate and select 2 points, this point and this point, because this grade is uniform, so you can insert 7 and you may apply to draw all. This is not 7, this must be 6. Right, so the internal pile has been drawn, but you can see these will be only at the 60 feet, right? So you can see this is the base. So now you have to select all of these pile, and now you have to replicate it to the 80, so it will become 80 feet pile, right? So bring it into 60, click on apply. So now these has been replicated, and now the length is become 80 feet. Now the length for the other column piles is 60. Now you have to select again the 30 inches dia, and this time it will be 60. And again you have to draw these one by one. So this is how you model the piles in ETAB. This has already been done in the previous session as well. This is also the edge. Right, so now again select the pile dia 24, which is 24-inch die, is the corner one, and its length is 60 feet. So now this is done, right? If I only display the basement, and if I show the 3D, if I click on the rendered view, you can see that the middle pile length is greater as compared to the edge and the corner, because we have replicated into the 80. So now this pile is 80 and this is 60 feet, right? So this is the confirmation whether it is 80 or 60 or not, right? Again, the next step is to define or apply or assign the spring properties to the piles, right? So again, I have already explained in the previous session, there are different equations and different formulas which you can use for the calculation of the spring constant to represent this one. But this time I'm using the simple formula, which is the pile capacity divided by allowable deformation, which will give you the stiffness in kip per inch, right? So for the first pile, the 30 inches dia and 80 feet length, the stiffness comes out to be, this is the vertical stiffness at the tip, which is the 4800 kip per inch, right? So this is the 10 mm deformation allowable by the code. And the horizontal stiffness, you have to multiply 10 times the vertical stiffness. So it will become 4800 kip per inch. Similar for the other pile, second pile, which is the 30 inches die and 60 feet length, and its stiffness comes out to be 2880 kip per inch, and its horizontal lateral spring constant, if you multiply with 10, it will become 28800 kip per inch. And similar for the third pile, which is the 24-inch die and 60 feet length, and this stiffness comes out to be 2352 kip per inch, and this is the lateral if you multiply with 10, right? So you have to define these spring in ETAB. You have to go to the define spring properties, point spring, and you have to add new property, and let us call it as KV1, and its value is 4800, and you have to write it in Z. I will define only one, and you can define the rest of it. It is very easy. So you have to write this is kip per inch, and you have to click OK. Now you have to click, this is the KH1, and you have to make the 0, and you have to insert the value of lateral springs in X and Y direction, right? So you have to define similarly KV2, KH2, and then again the KV3 and KH3, right? So let's do not waste time on this, because this is a very easy job, and I have just defined the first one. You can define another two, and again we have to select all of the piles, and you have to divide it into different segments, divide the frames, and divide into, if it is 80, so if you divide it into 40, it will be 2 feet, and the other one will be 1.5 feet, and you have to click on apply. So it will be divided into different segments, because you can see it will become very heavy file. You will experience this when you start analyzing these springs, right? And now you have to select one by one the piles, right? You have to assign each pile each springs, because it will take time if I select one by one, but I'm just selecting only one. For example, if I select the edge one, for example, you have defined the KV3 and KH3, then we have to select this pile, and we have to assign the specific springs to these piles, right? So let me show it in here, which I have already assigned to these model, right? So this is the edge corner pile, in which if I show it to you, so this is the corner pile, and if I click on the point, so you can see in the assignment the springs has been assigned, which is the KH3 horizontal spring assigned into the edge one, right? If I click on the interior, And if I right click, so you can see it is named as an H. It means it is KH1. It is the horizontal, right? In this way, you have to assign the springs to the piles. The next step is to divide these piles, which we have done, and then assign springs to each mode, and then run the analysis, right? So before going to the analysis mode, there is another requirement, which is the pile capes, right? So pile capes are designed as a two-way slab as per ACI, and the thickness of the pile cape is limited by ACI 31840 in section 13.4.2, that the overall depth of the pile cape shall be selected such that the effective depth of the bottom reinforcement is at least 12 inches. So the thickness of the pile is at least 12 inches. So we will select 24 inches thickness as per my experience, right? And there is another some restriction on the pile capes as well, that if you are designing a single pile, for example, for the single pile cape, its size should be 1.5 D, which is D is the diameter of the pile. And for the pile group, if you are designing a structure and there is a piles in a group, for example, if you design the piles for a single column and you design two piles under one column, so that will become group piles, and the center to center distance between two piles should be at least 3D, and D is the diameter of the pile, right? And then again, we have to check for the punching and all of these, right? There is another requirement of the code, which is the grade beam, that the all pile capes having single pile shall be connected through grade beam, right? And the design of the grade beam is same as we have done in the strap beam, right? So if you provide the grade beam, so it will reduce, or you can say minimize, or you can say finish the punching issue for you, right? Because when you place the grade beam, or you can say the beam in any column under the column or under the piles, so there will be no punching issue, right? So normally it is connected to this grade beam in order to transfer the stresses uniformly and also minimize the punching issue, right? So this is the overall procedure for the piles. The next is the pile cape, in which the minimum size is 1.5 D. Right? So in our case, the diameter of the pile is 30 inches, which is 2.5 feet. So if you multiply 2.5 with 1.5, so it will become 3.75, right? So this is the minimum, but we will take the pile dia, we will multiply with 5, right? So no, this is 4. So it will be 10 feet, right? So we will take the pile cape thickness, the size of the pile cape is 10 cross 10, because it will give the relaxation to the piles in reinforcement, right? And there will be no such an issue in the development lengths of the pile capes, and all of these requirement will be fulfilled, right? So you can select any size as long as you fulfill this minimum criteria, right? So we will be designing the pile capes 10 cross 10 for each under each column. So again, you have to go to the basement, which is the pile cape level. You can see raft level, and you have to define the section for the pile cape, and you have to write 24 inches. You can select any sizes, but the least is 12 inches. But if you increase it to 24 or 36, it will give you relaxation, the reinforcement of the pile cape, right? So this is the 24 inches, and click on OK. Now you have to draw again. This is the same procedure which we have done in the modeling of the isolated footing. You have to divide it into 2. So you can select the center. So let us divide it into two. Because this file is very heavy and I think I have disabled the floors. And you have to select this, and again you have to replicate it like what we have done in the past, right? And place it under the file, right? So now disappear the columns. I will only draw some of these because it's taking too much time because the file is very heavy. And let me take it 6. And again, you have to select like this in 2 points. The correct modeling of the piles and pile cape is very important. So you have to be very careful during this phase. Right, so now you can select it and give 6. Right, so this is the overall procedure, how you can model the pile capes. Again, select this and make this 6. Again, if you select these, make it 1. It will be like this. And if you select these, so this is the overall modeling of the pile capes. Now the next step is to define the section for the grade beam. Right, we have to define the grade beam, and you have to take the depth equal to the depth of the pile cape. We have selected 24, so we have to take 24 plus 24 beam. You can also increase or decrease the sizes, but if you decrease the size, it will give you more reinforcement. So now you have to show the grids. You can draw the quick using the quick command and select P24 plus 24 and draw these beams. Right, so now this modeling has been completed. Right, so these are the pile capes with connected with the pile, and these pile capes are connected to with each other through beams. Right, so the next step is to run the analysis and check for the reinforcement in all of these, which I have already run the analysis. And if I show the rendered view, so you can see this is the 12-story building, and it's under the, there's pile capes you can see, and there's grade beams connected to the piles having single pile cape. Right, so this is the whole story about the modeling. Now the next phase is to design. So I think it took 2.5 hours to run the analysis. Right, last night I have run the analysis, and let me display the reinforcement in the pile, right? If I click on apply, you can see it's very loaded. And if I display only the piles, let me move these grids as well. So now you can see the design has been run for the piles, and you can see the reinforcement in the piles, which is, I think it is minimum, and it is 7.06 inch square. If I display in percentage, it will be 1%. Right, so you can see that the piles has been designed using all the combinations, because I have designed it for the all load combination using earthquake forces as well. Because if I right click on it, because last night some students requested me to design it. So because this file is very heavy and you have to run it again to check for which combination it has been designed. But if I show you the design combo that I have designed it for the all load combinations, you can see it consists all of the gravity load plus the earthquake, and the reinforcement it required is shear reinforcement as well. And you can see that the shear reinforcement it required is 0, 0. This is because it has been confined by the soil all around, and there is no need of the shear reinforcement. But the flexural reinforcement is the minimum reinforcement, which is 1% for each of the pile for 24 inches and as well as for the 30 inches as well. Right. So if I select all of these and start design again, so it will take 30 minutes or 35 minutes. So let's do not waste our time on this, but because we know that this it has been designed on the minimum reinforcement, and we have to provide the minimum reinforcement or shear to confinement of the concrete, right? It is 0.3 inch square per foot. So the reinforcement in the 30 inches diapile is 7, right? It is 7 point, we will take it 7.1. And for the 24 inch, it is 4.5, you will take it 4.6. So let us go back to the design. So if you design it only for gravity, so you can also write that, because we have designed it for the earthquake as well. So we will need the AS, which is the area of steel, which is 7.1 square. And same is for this 7.1 AS is equal to 7.1 inch square. Right, so the next is the 24 inches, in which the reinforcement required was 4.6. AS is equal to 4.6 inch square, right? So let me end this Zoom meeting, and we will start another meeting in which we will design the number of bars for the piles, the shear reinforcement, and then we'll move towards the design of the strap beam and the pile capes.